Division of whole numbers can be written as multiplication by a fraction. And these rules are going to help us when we talk about division of fractions. So 6 divided by 3, the same thing as 6 over 3 as a fraction. But I can rewrite 6 as 6 times 1, and I can rewrite 3 as 1 times 3, right? When you multiply by 1, you're not changing the number. But this should look very familiar as this is a multiplication of fraction, right? If I just cut right down here, I have 6 over 1, which is just 6, times 1 over 3, which is 1/3. So 6 divided by 3 is the same thing as 6 times 1/3. Instead of dividing by 3, we multiply by the reciprocal, or the flipped version of 3. So 3 is the same thing as 3 over 1. The reciprocal of 3 over 1 is just flipping the numerator and denominator. It becomes 1 over 3. And this will work for any choice of whole numbers. It will also work for fractions. But let me show you a diagram of this. Diagrams are very hard to show for large numbers because of the way of what we have to do in here. But I can show you for small numbers, and it can show you how it works in general. So 2/3 divided by 1/4, we have, of course, the starting amount was 1, and then I cut it into 2/3 right off the bat. And then now we're going to look at, ignore these lines. I'm going to cut this into fourths now. So I'm going to cut it here and then there. So that we're going to have fourths going this way is 1, 2, 3, 4 fourths. And to do the division, what we're doing is we're going to rearrange this into complete fourths, right? We're missing a part here, 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 and here. I'm just going to take this part and move it here, and then this part here and move it here. What that does is it gives me 2 complete fourths. And then if you look at this last fourth, I have 2/3, 2 boxes out of the 3 that are necessary. So I have 2 full ones and then 2/3, or 2 and 2/3 is my answer. It's because of this rearranging that it's just not, diagrams aren't very feasible for doing a lot of these types of things. It's better to know the algorithm than it is to understand the visual. So you can do it very quickly with the algorithm. We're going to change 1/4 into multiplication by the reciprocal. So I changed division to multiplication, and then I flipped 1/4 to make it 4 over 1. And now we're just multiplying. 2 times 4 is 8, 3 times 1 is 3, and that is the same thing as 2 and 2/3, just like we got in the algorithm, or the diagram. Okay, 2 over 1, we never divide fractions, we instead multiply by the reciprocal. 2 times 4 is 8, 1 times 1 is 1, I get 8. There are 8 1/4 or quarters in 2. That's what that means. Once again, 4 over 1, we're going to multiply by the reciprocal. I can cross cancel the 4's, and I get 5 over 1, which is just 5. There are 4/5 in 4. That's again what that means. It's hard to understand that. It's easier to think about things like, right, 2 divided by a half. There's going to be 2 halves, or there's going to be 4 halves in 2 because each one is a half. But some of these things, like this one, is a little bit harder to visualize easily. So 7 halves times the reciprocal of 3/4 is 4/3. I can cross cancel. Divided by 2 is 2. 7 times 2 is 14. 1 times 3 is 3. 3 can go into 14 4 times evenly, with 2 remaining. Okay, 4 is 4 over 1. So I'm going to multiply by the reciprocal of 4, which is 1 over 4. And then I can cross cancel. 8 divided by 4 is 2. 4 divided by 4 is 1. I can also reduce here, right? 2 and 12. I can divide by 2 and divide this by 2. Give me 6. 1 times 1 is 1. 6 times 1 is 6. I get 1/6. Again, division, it's just mixed numbers are just, it's better to work with improper fractions. Mixed numbers are you can do it, but it's going to be very confusing. 2 times 3 is 6, plus 1 is 7. I'm going to divide by, I'm going to change this first into an improper fraction, then flip it. 8 times 5 is 40, plus 3 is 43. Now I can multiply by the reciprocal. I can cross cancel here. It gives me 28 over 43. That cannot reduce. Finally, 3 over 1 divided by 2 over 1 is going to be 3 over 1 times 1 over 2. Going straight across, 3 times 1 is 3. 1 times 2 is 2. This is going to be 1 and 1/2. 2 can go to 3 one time evenly with 1 remaining. Notice that in all of these things, I multiplied by the reciprocal of the second fraction. I changed division of the fraction to multiplication by the reciprocal. I never changed the first fraction. There's always 2, 2 in there, 4, 4 in there. Here I changed this portion, but I kept the same 7 over 2. You're always going to keep the first fraction of the first number the same. Then you're going to multiply, change the division to multiplication, and change the second fraction, the one right after the division. Don't get that confused. Don't change the first fraction. It's always going to be left the same in the process. 3 was left the same as 3 here. Okay, let's look at some application type problems. We have a recipe calls for 3 potatoes, 1.5 cups of salsa, 2 pounds of ground beef. How much is needed for half of the recipe? Half of the recipe means we're going to just cut it in half or divide by 2. So we have 3 divided by 2 for the potatoes. And then this is the same thing. We actually just saw it up here, right? 3 divided by 2 was 1.5. Same exact process. 1.5 potatoes. 1.5 cups of salsa divided by 2. Going to change this to going to be 3 halves here. 2 times 1 is 2, plus 1 is 3. And then 2 over 1. Change this to 1 over 2. Multiply by the reciprocal. 3 times 1 is 3, 2 times 2 is 4. So 1/2 cups of salsa cut in half is 3/4. Finally, of course, 2 pounds of ground beef divided by 2 is going to give us 1 pound of ground beef. Now, if the part of the recipe calls for 1 quart of water, 1/3 cup milk, 2 cups beef bouillon, and then 4 large carrots to make 6 servings, approximately how much of each ingredient is in a single serving? Well, if they make 6 servings, then all we need to do is divide each one of these things by 6, because that's approximately, you're going to have 6 of each ingredient in a single serving. So we're going to have 1 divided by 6, which is going to be 1/6 quart water. Okay, we have 1/3 divided by 6. This is for milk. It's going to be 1/3 times, right? This is 6 over 1. 1 over 6. Going straight across. 3 times 6 is 18. So 1/18 cup milk. 2 beef bouillon is going to be 2 divided by 6, or 2 over 1 times 1 over 6. I can cross cancel by 2. Going straight across, 1 over 1 times 3 is 3. So 1/3 is going to be cubes. And then 4 large carrots divided by 6. 4 over 1, 6 over 1. I'm going to multiply by the reciprocal. Once again, I can cross cancel. I can divide both by 2. And then going straight across gives me 2/3 of a carrot. So that's what we expect in each serving with this situation. Okay, a 100-foot tree needs to be cut into 1¼ feet. How many of these sections should we expect when we do this process? So we're going to divide a 100-foot tree evenly into sections that are 1¼ foot. So all I need to do is do the division. 100 feet divided by 1¼ foot gives me what? Well, 100 divided by 4 times 1 is 4, plus 1 is 5. And then I'm going to multiply by the reciprocal. And I can cross cancel, right? 5 can go in 120 times. And going straight across, 20 times 4 is 80. 1 times 1 is 1. So we expect 80 sections. And because it was even, we expect 80 sections evenly. Of course, there's probably going to be some waste in that. But if you can cut it exactly into 1¼ feet, then you would get 80 complete sections, and there'd be nothing left of the tree. Okay, if you ran 920 miles in 3.5 months to train for a marathon, then on average, you split this up over this time period for each month. So we're going to break it up evenly into the 3.5 months. That's the same thing as division. That's what division finds. 920 divided by 3.5. So 920 over 1. 2 times 3 is 6, plus 1 is 7. Multiply by the reciprocal. And let's see if 7 can go into 920. It cannot. So I'm going to go straight across. 920 times 2 is 1840. And 1 times 7 is 7. So I'm going to use a calculator to find how many times 7 can go into 840. And go in there 262 times evenly. Doing 7 times 262 gives me 1834. And you can see that there's going to be, if I take 1834 out of 1840, I get 6 remaining. So in other words, we ran, or you would ran, if this was the case that you were running, you would run 262 and 6/7 of a mile per month on average. Now that we've talked about division of fractions, we can talk about the full order of operations, the full PEMDAS process. So PEMDAS or GEMA, as I said before, the same steps. Nothing's changed here. Fractions are just a different type of number that we're working with. So parentheses is done first, except here we're not going to do 3 divided by 4. We're just going to leave it as 3/4. And we're going to do the cube of that, which is going to be 3/4 times 3/4 times 3/4. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. That would be our answer. Okay, we're going to do exponents first before the multiplication, right? Because this is right next to this number, so it's going to be multiplying there. We're going to do the exponents first. 2/3 squared is 2/3 times 2/3. I can write it out, or I can just do 2 times 2 is 4. 3 times 3 is 9. And now I can multiply this through. I can cross cancel, however. Divide by 3, divide by 3. 1 times 4 is 4. 5 times 3 is 15. So 4/15 is my solution there. Okay, order of operations says division comes before addition. So I need to divide this first. We never divide by a fraction though. We multiply by the reciprocal. And I'm always going to flip the fraction after the first fraction right after the division sign. So I'm going to flip only 2/3. I'm not going to flip anything else. I can cross cancel here to give 3/4 still hasn't been changed because addition is done after multiplication. 3/4 multiplication and division. I have 2 times 3 is 6. 5 times 1 is 5. And now I need to have common denominators because we're doing addition here. 4 times 5. 5 times 4. Going to give me 15 over 20 plus 24 over 20. Or, let's see, 39 over 20, which is the same thing as 1 and 19/20. Okay, exponents are done first before multiplication and division, so I need to do 2/3 times 2/3. We actually already talked about that up here. That's going to be 4/9. 2 times 2 is 4. 3 times 3 is 9. And then we can multiply by the reciprocal. So multiply by reciprocal. We can cross cancel the 4s. 1 times 9 is 9. 5 times 1 is 5. 5 can go into 9, 1 with 4 remaining. Okay, now we have parentheses that I need to do first, and then I can do the exponent, and then I can do the division. So I need to do both of these things individually, so I'm going to do them at the same time. 2 over 1, I'm going to multiply this one by 3 over 3 to get common denominators, because I'm subtracting fractions. And here I'm adding fractions, and the least common denominator between 4 and 6, I could just do 4 times 6, right? That'd be 24. But 4 can go into 12, and 6 can go into 12. And that's the least common denominator. 4 times 3 is 12. And 6 times 2 is 12. So this gives me, it's going to be 6 over 3 minus 1 over 3. That's still being squared. Then we have 3 over 12 plus 2 over 12, because 2 times 1 is 2, and 6 times 2 is 12. Okay, now I can actually do the subtraction and addition. I'm going to get 5/3 squared divided by, and it's going to be 5/12. Leave it as an improper fraction. It's going to be easier to work with when you're doing the work. So we have 5/3 squared. 5/3 times 5/3 is going to be 5 times 5 is 25. And 3 times 3 is 9. Okay, now we are dividing by a fraction, so we're going to multiply by the reciprocal. And I can cross cancel quite a bit here. I can cross cancel the 5. 5 divided by 5 is 1. 25 divided by 5 is 5. And I'll do a different color here. 9 divided by 3 is 3. 12 divided by 3 is 4. 5 times 4 is 20. 3 times 1 is 3. 3 can go into 20 6 times evenly. 6 times 3 is 18. So there's going to be a 2 for a remainder. So 6 2/3 is my solution to this problem. Okay, we want to evaluate these special cases. Same process though, order of operations still applies. We have 2 things inside of a fraction. 4 and 3 is 12 when I multiply them, so that's my common denominator. There is no other least common denominator. And here I can get common denominators of 4. Just multiply this one by 2 over 2. So I get 9 over 12 minus 4 over 12 times, this is going to be 2/4 minus 2/4. This one gives me 5/12 for this whole thing. And then 2/4 minus 2/4 is 2 minus 2 is 0. 0 over 4 is just 0. And anything times 0 is 0. So 0 is my answer for this case. Now in this one, we have division by a fraction. So I'm going to multiply by the reciprocal. And right here is a problem. We have a division by 0, which you cannot do in mathematics. So this is undefined. There is no solution to this problem. All right, Bill earns $10 every hour he works up to 40 hours. Any additional hour past those first 40 hours in a week, he will earn overtime hours. And for overtime hours, he earns time and a half wages. So he makes extra money for those extended hours. If he works 56 hours in a week, how much is his gross pay for that week? Not his net pay, right? That would be after taxes and everything like that. But gross pay is easy to calculate from how much do you make per hour and how much did you work. So 56 hours in a week, and we know that 40 hours are normal hours, but every hour above that is going to be overtime. So 56 minus 40 is 16 overtime hours. So we can take this in two parts. We have the 40 regular hours that he works, and he makes $10 for all those 40 hours. So he makes 10 times 40. That's how many dollars he makes in that original 40 hours. However, for these 16 hours, these 16 hours are going to be not times by 10, but times by 10 times by time and a half. Time and a half means 1.5 times. So he actually makes more money when he does that. You can think of it like this, like I have written here, or you can think of it as 10 times 1.5. So for the first 40 hours, it's going to be 10 times 40, or 400. He makes $400 for the first 40 hours. Now for the next 16 hours, he's not going to make $10. He's going to actually make 10 times 1.5. 10 times 1.5. 2 times 1 is 2, plus 1 is 3. Going straight across gives us 30 over 2, which is 15. He makes $15 for every overtime hour that he works. So you can either do it like this and do multiplication straight through, or you can just write it as 16 times $15 for every hour. There's 16 overtime hours. 16 times 15 is 240. So in total, he makes the addition between these two amounts. And that's going to be $640.